Okay, welcome back to another presentation. We're going to be talking about colorants and metal oxides today. And um, sorry, I'm just making sure my screen looks good for you guys. Okay, here we go. Color metal oxide stains and opacifiers. I'm first going to talk about the metal oxides, the ones that we keep mostly in our studio. And then I'll discuss a little bit more about some other materials like opacifiers. And so here we go. This is the first metal oxide, probably one of the most stable oxides, cobalt. Cobalt is typically blue. It's a really, really strong oxide, a really strong coloring agent. Especially if it comes in the oxide form right here. So the sources that we have in the studio are cobalt oxide and cobalt carbonate. Just something to touch on as we go through all of these materials. You'll see that most of these materials either come in the form of an oxide or a carbonate. The thing to note about the oxide form is that it's a more intense version of the material because there's typically one metal molecule to each oxygen molecule. Therefore, it's a really intense or saturated source for the material. If it's in a carbonate form, then that means it's a little bit more diluted because the carbonates are CO3s. And so depending on whether it's an oxide or a carbonate, that might give you some a little bit of a difference in color saturation, color hue. But using the carbonate form might give you a little bit more control over the intensity of the color because you can incrementally add it in smaller amounts. So anyways, getting back to cobalt here. Most of the time, you'll have a blue. If it's cobalt oxide, it's a really dark blue. And then usually the cobalt carbonate tends, especially in glazes with heavy alkalis, the earths, alkali earths, you can tend to get more purple and lighter colored blues. Some of these materials like iron, copper, and cobalt, manganese, if you have a lot as far as percentage wise in the glaze in the oxide form, you can tend to get black. Many times black is made from a combination of iron, copper, cobalt, and then manganese by itself. We'll get into that later. Okay, let's move on to copper. Again, this comes in an oxide form or a carbonate form. The most common use of copper is copper carbonate. It actually looks green. It's kind of like a light minty green type of color hue to it. This particular colorant will produce different colors, whether it's in oxidation or in reduction firing atmospheres. So if it's in oxidation, you'll tend to get blues and greens. Depending on the content of the glaze, whether it's an alkali metal or alkali earth. But in reduction atmospheres, you can get all sorts of different colors, including red. And in raku firing, you can have an abundance of copper in those glazes, and you'll get a really wide color response. Including anywhere from copper penny hues to greens, magentas, reds, yellows. And then in normal high fire reduction glazes, you can have hues anywhere between green, blue, and red. So, okay, moving on. These are some more glaze examples. You can see right here, this would be a reduction. Oops. This would be a reduction version of probably an Uribe. That's a traditional Japanese glaze. It looks a little bit more matted than usual, but you can see here where the most likely it was in direct contact with the flame, it turned more of a red. And where it was not in direct contact of the flame, it's more of this green hue. This is Ryan Greenheck, so this is oxidation. These are probably cone 6 fired porcelain pots with copper used to color the to get the green color there. Again, oops, no, wrong direction. Yeah, but here we go. This is John Glick. He's a really famous potter. This is a traditional copper red glaze, so with the inclusion of tin in that glaze, it will favor red. It looks really good on porcelain and is a traditional Chinese glaze. And it can be rather difficult to achieve. This is a really beautiful example of a copper red surface. Chrome. Chrome, you can, depending on the other ingredients, again, you can get different colors ranging from green to pink. Typically, chrome usually favors green. We have chromium oxide in the studio as well. These types of greens are different from the copper greens, though. They tend to be a little bit more like forest green or like medium deep greens. And then I believe it's in like heavily alkali earth glazes, you'll get pinks. I think it's in conjunction with like magnesium or calcium, you'll tend to favor pink. Okay. Iron is the most common metal source. It's one of the most abundant materials in clay, in the Earth's crust, and therefore it's obviously embedded into clay. Sources can be red iron oxide, black iron oxide, and again, like I said, you can color your glazes with using different clays like ball clays that have traces of iron in it, including this glaze right here. The only source of the iron is from ball clay here, which promotes these kind of orange colors. Typically, the colors that you get, you usually associate with iron, and in reduction, you'll tend to favor like oranges, rust colors, earthy tones. Sometimes in heavier percentages, it'll tend to favor like a brown or a black. A good example would be a Temmaku glaze, which is a really beautiful, rich brown to almost black glaze. That breaks a little bit more of a rust to red color in thin areas. There are other glazes called celadons. Again, it's another Asian glaze. Celadons are a Korean glaze. They have a little bit, with trace elements of iron, you'll tend to favor green to blue hues. In glazes that are favored with calcium. And then the less iron content you have in those glazes, the more blue it will present, and then with more amounts of iron, it will favor green. In oxidation, you can get all sorts of different colors, depending again on the content of the glaze, whether it favors alkali metals or earths. You can get, clay reds, like terracotta reds, browns, to even gray. This is a great example of the Temmaku glaze that I was talking about. This is Phil Rogers, an English potter. You can see these really rich, dark, black to brown colorations. And you can see here it presents more of a rust red where it's thin. This is another version of a Temmaku glaze. It's just a little bit thinner. And so it's favoring a little bit more of the clay body hue coming through it. So it's a really, really beautiful, rich glaze. These are Uh, Examples of Chinos, which is a feldspathic glaze, typically like a sodium feldspar, a lot of sodium feldspar, a lot of clay. And you can see how the hues of iron are coming through from the clay body and the trace sources of iron that's presented in the glaze due from the clay addition. And you can see these really beautiful um, variations of iron kind of piercing through the white part of the glaze, especially over here. So you can see, these areas are really due to interaction between the glaze and the clay, and because the clay body is so dark, it's going to push those iron, rich brown to orange colors through. This would be an example of a celadon. And you can see here, this is more of a blue celadon, so there's probably lighter amounts of iron. And here it favors a little bit more green. These are really well-known techniques for using celadon. So you can see a lot of potters will use a porcelain or like a white clay body, and then carve into it. And then the glaze, as it sits in the crevices, will present more of the color of the glaze, and then it breaks, revealing the clay body in the thin areas. So really beautiful glaze. Okay, the next source is manganese. I don't have manganese. It's toxic. But it's an excellent source for black. It's not toxic in glazes. As you can see, these are Lorna Meaden's functional pots. She's a really great American potter. She soda fires. But you can see here this black glaze is on a functional vessel. So, it's definitely safe to use. But you can get a range of colors from brown, purple to black. Most of the time it's black. I believe in high concentrations, you can also get real metallic looking surfaces. So something to experiment with there. Again, this is more of Lorna Meaden's work. You can see she's very design oriented. Her work is really nice and utilizes this manganese base glaze. Okay, vanadium. We have vanadium pentoxide. It is a natural forming metal. It's used to make yellows. I really don't use it very much. The yellows, I don't really care for it too much. However, like I said, you can get pretty bright yellows depending on the ingredients of your materials. It looks like this one right here is definitely an alkali metal, because you can see the craze line, so it's definitely high in sodium, I'd imagine. And so you can get a pretty nice yellow there. Probably as you add more alkali earths, like calcium and magnesium, it'll probably favor more of like a gray to pale yellow. If I want a really bright yellow in oxidation, I might just use a yellow stain, but you're welcome to experiment with this material. Nickel is a really interesting metal. You can get a lot of different colors from it. The sources we have are black nickel oxide, green nickel oxide, nickel carbonate. We keep black nickel oxide. And you can see, the array of colors from gray to brown, green to brown. There's even this purple that you can obtain. And notice that these really bright colors with nickel are in association with zinc. Not quite sure of those ratios. It's something that we could experiment with. Again, I don't use nickel a whole lot, so I don't have a tremendous amount of experience with it. I do, however, can show you, this is one of my bottles, macrocrystalline glaze. And with the addition of zinc, you can see the multiple color ranges. So in the zinc crystals that form, it creates a blue. And then in the background, in a heavily alkali glaze, it will present this kind of orange to brownish color, which creates this really beautiful contrast in color. So, like I said, it is a real versatile material. Okay, that's pretty much it for the metals. Now we can talk a little bit about stains. Stains are basically um, fritted, coloring oxides that are basically they're stabilized in a glass. They might have like some other materials like clay or like an alkali of some sort to help favor a typical color range. But basically, they stabilize the color inside of like this, uh, recipe. Um, and then you can add these stains to glazed bases, and it will transfer the color pretty close to the color that's presented when you receive it. The suppliers are Mason, Spectrum, and Degussa. Degussa creates high temperature stains. So you can get like bright reds and bright oranges at high temperatures, which is hard to do. They tend to be really expensive though. We keep a lot of Mason stains in our studio, so you definitely have a good variety of materials to choose from there. You have to be careful when adding stains. They are refractory, so they will raise the melting temperature of your glaze at higher percentages. So if you're getting past like 8, 9, 10%, you need to start observing the changes to the surface quality of your glazes. So just be careful with that. Okay, opacifiers and textures. Okay, so the first one is a really interesting material. You can use this for color and for texture. This is more of like a visual texture, rutile, and you can get a lot of really crazy glaze reactions from using rutile, and depending on whether it's granular or powder. So basically there's two courses you can get. The granular course, which is almost like these little pebbles, and it will create these really interesting spots all over your work with color response. Or if you want a more systematic inclusion, then you would use the powdered form. These are some really interesting surfaces that you can get from rutile. You can see it tends to favor between like a gray to blue, sometimes a brown color to a purple color, like over here. It's kind of sporadic. It depends on the thickness of the glaze, which color will present, and what clay body it's on. I've seen really intense like blues to purples and browns on porcelains, and you can get some really, really interesting results with rutile. Tin is an opacifier. Basically, you can turn a glaze. You add additions of tin to help make it more white and more opaque. Tin is an amazing material. It is the best opacifier in my opinion because it offers a really smooth and consistent melt. It doesn't add refractoriness to the glaze, so you can have these really clean, glassy, milk white, opaque surfaces with tin, but you have to be careful. It's really expensive. Another source is titanium. I should probably have titanium before tin, but anyways. Titanium, you can add textural additions to the glaze. You can see here, it comes in the form of titanium dioxide. It is a crystal former, so you can use it as an opacifier in macrocrystalline glazes. You can use it as the main crystal former. Right here, like especially in the background, you can tell when the glazes use titanium because they have these background crystals that grow and that are really, really consistent in the background pattern with these macro crystals that grow in the front. So it's really interesting material to use. Again, similar to what tin would provide, zirconium comes in the source in our studio as Zercopax. It is an opacifier, it's a crystallizer, but in higher percentages, it tends to be a little bit more refractory, and the surfaces aren't as smooth as the type of opacity that tin can provide. However, Zercopax is cheap. So you can, service, the opacity of the glaze a lot cheaper as long as you keep it, under levels of like 8 to 10%. As long as you're under that, you won't change the nature of the glaze too much. But you start getting into 8, 10, and percentages above that. It will prevent the glaze from melting, or it will crystallize it a lot more, and so it will appear to be really, really dry. So you have to be, careful of how you include Zercopax or zirconium, which would be the oxide. I believe that's it. Yep. Those are all of the materials that we have to color and to change the surface of our glazes. And you should feel free to experiment with all of them. All right. I guess that's it. So thanks a lot, and I'll see you next time.